and understand what's going on. So I've just pressed the record button. Good, so we're recording. Now, as I say, you don't need to copy this out. You just have to pay attention to the explanation. We had a survey of 30 people, and they weren't arranged in this order when we surveyed them. In fact, when they answered their answers in the raw data, which was at the top of the paper, you see that how the answers were mixed up, all different kind of answers in no particular order. But we took that set of raw data and we sort it out into a nice frequency table where we have everything neat in an order. And from that order, from this frequency table, I was able to draw this um, drawing here of a line of the 30 students arranged in order from the least to the most. And you probably remember that you just have to do that if you have to find the median. Because if you have 30 people, you kind of look for the middle person or the two middle people in this case. And whatever number of books they have, that would be the median. However, so you're familiar with sorting out or everybody uh, in your survey already. And we're going to sort this out for the probability. Okay, so let me just mark this here. These two people had one book, BK. These three people had two books. These five people here had three books. I hope you could see it, Thelma. These six people here had four BKS, four books. These seven people here had five books. These four people here had six books. And then the last three people had seven books. Okay, this is me here. Big, big head me. And they cover my eyes, they blindfold my hair, so I can't see anybody. And they spun me around to get me very dizzy. You ever see them people playing pin the tail on the donkey at a birthday party when you was a little child? And they blindfold you and they spin you around and then they say, go pin the tail on the donkey. And you just had to go dizzy and stick the
Yeah.
thing. Right. So it kind of like that. This is me here spinning around blindfolded, having to choose a student at random. So I'm not sure who I'm gonna choose. I'm gonna walk to this line and just pick somebody out, and I wouldn't be able to see the color of them. I wouldn't be able to know if that person had little bit books or plenty books. I'm just gonna randomly choose a guy from this group of 30 people here. And the question that they're asking me is, how likely am I going to choose a guy? Let's read over the question. Determine the probability that a student chosen at random has less than four books in his or her bag.
Mm.
That would be like three books or two books or one book, right? That
Mm.
would be um that would be these guys here. These guys here, which I sorted out, have less than four books. But remember, I just draw it sorted out. But in reality, Imagine if all the children was mixed up in class and they weren't sorted out, and I spinning around, and I just have to choose a guy. What is the likelihood that I am going to pick somebody in that mix of the class that actually happen to be one of these guys, right, in the yellow zone? You all seen the scenario, you're hearing my story. You with me on that story?
Yes, sir.
We have the 30 guys, they lined up. I spin around, but then they mix up the students. They mix them up, and then I have to try and choose anybody. And they want to know how likely am I going to choose a person that has less than 4 books. So I supposed to just keep my blindfold on and run around the classroom and grab one person only and check that person and say, hey, how much book you have, way? And then the person will tell me that I had, and they'll tell me if they had 3 books or 2 books or whatever, how much books they had in the bag. And then what we trying to measure out from that is how likely was I going to catch somebody in class with 3 books or less. Okay?
Yeah.
That is what's supposed to happen. I supposed to just catch one person, and we want to know how likely I would I catch that person with less than 4 books. However, when we are calculating the probability, we change the story. I cheat. When we are calculating probability, first of all, I line up everybody in order. Okay? Instead of mixing them up randomly, I sort them. Then the next thing I do, I take off my blindfold and I could see everybody. So you understand what's going on here? I cheating when I have to figure out probability. Let me roll off that blindfold there. I could see everybody. The next thing I am going to do in breaking the rules, instead of trying to catch one person out of the 30, I go in and check every single person in my survey. So I am going to check the first guy first and say, open your bag, let me see how much book you have. Then I'll go into the next guy. Hey, let me see how much book you have. That kind of remind me of when they searching all you for scratch bomb in school, and right? Let me see how much book you have. Let me see how much book. And I'm gonna check everybody. How much tries I'm going to try and all.
Yeah.
30 tries, and
Yeah. Yeah.
30 tries. I have to try 30 times. When I check in, the number, all the tries is 30. Now, out of the 30 tries that I are doing with my eyes open, with everybody sorted, how many times I'm going to successfully find a student with less than 4 books? It would be these guys here in the yellow zone, and these are the guys with less than 4 books. So let me see. 1, 2, 3,
10.
4, 5, 6, 7, 8, 9, 10. 10 guys. 10 guys I'm going to be successful in catching them. So my answer, if I get a fraction, 10 over 30. And I'm going to reduce that fraction. 10 over 30 could be reduced to 1/3. So my answer is, my probability is 1/3. Okay. Now, that's your answer. Your probability is 1/3. Let me show you that 1/3 as if we were to draw a picture of 1/3, how 1/3 does look like, boy. If I have a circle here, 1/3 is about this amount.
Or the class.
Okay. So that's 1/3. Listen, you see that circle there? The amount shaded of it, or the fraction, shows how likely you're going to succeed in what you're trying to do. So if this thing was full up of green, that means I would have surely guarantee 100% of the time get through with what I was trying to do. And the smaller this fraction is, the least, the less likely you're going to get through with what you're trying to do. So if I had a smaller fraction, suppose my fraction was not 1/3, suppose my fraction was only about 1/10. If my fraction is 1/10, would I be more likely to get through with something or less likely to get through?
Less
Less
likely
likely.
to get
Less likely. Here we have 1/3, which we more likely. And if some girl, like in Dumb and Dumber, say that you have a 1 in a million chance of getting through it with her, then you have a little skinny line alone. Right? You remember the movie Dumb and Dumber? The guy asks, the stupid fella asks the girl,
yeah.
Yes,
what's the
yes.
chances that you get through? And she say, like 1 in a million. And he'd say, yes! At least I have a chance! Okay. So, you could see 1 in a million would have been a fraction there. 1/1,000,000. A very small fraction. So now that was your lesson there on understanding how probability is a fraction. And we could even show it in a picture to show you how likely you will get through with what you was trying to do. In our case here, we were 1/3 likely to get through with what you want to do. The most you could ever have is instead the biggest number you could have for answer would be the number 1/whole, 1/1. That is the biggest thing. The smallest thing you could possibly have, even smaller than 1/1,000,000, would be zero, a zero chance of something happening. So probability is always a fraction somewhere between the number 0 and the number 1. Any fraction ranging from that. It could never have a probability of 1.5 or something like that. That's ridiculous. Your probability is only um, how much of the circle is shaded. So in this case is 1/3. Any questions so far on what I was saying?
Yes, sir, I
No, sir.
understand.
No, sir.
Okay, now we cannot, we in CXC, we don't have time to draw 30 stickmen and color them up and go and turn around and spin around. And this is way too long to figure out the probability. So there must be a quicker way to figure out the 10 out of the 30. So let me look here at this group of, we're going to make use of this frequency table. And the frequency I told you often mean number of people. How much people is that I circle there?
30.
That would be 30, right? So the total, which you don't write down, is equal to 30. And you have done have that written down in your books, 30 underneath here. But
Yeah.
out of that 30, if I was to shade in yellow the number of people that have less than 4 books, well, these people here have only 2 books. These people here have, um, wait, these 2 people had 1 book. These 3 people
Five,
had
five, 10.
and 5. So then if I shade it here, I think that's it. Those are
Yeah,
the people that are, I could see it here. 4 books. We don't care about these other people here. We're not counting them right now. We only counting these yellow zone people. They are the ones that have less than 4 books. Again, the story comes like I am opening my eyes and I am no longer, and I'm cheating. I'm no longer randomly choosing people. I just go and macro every single person out of the 30 people and ask them how much book you have. And when I get my answer, it would be 10 of them. 10 because it's 2 plus 3 is 5. 5 and 5 is 10. This is 10 people in all. 10 people in all compared to the total 30 people. All right. You got that?
Yes, sir.
All right.
Yes,
And
sir.
it's recorded so that you could always go back whenever you get rusty on probability. Um, at least for this term, you could go back to this lesson and see the story in behind how you use your formula. You have to cheat to calculate your formula. Okay.
Mm.
All right, guys. So we're gonna let's see. We that would be it for today's class, right? We learned probability, and what is going on is that I have as we go through for the rest of the term with past paper questions, and we come up to probability, we will go ahead and use the formula, line up the people in our minds, and we could probably even shade them out, and we will work out our answer. And the more we practice it, the better. Okay. Um, that's it for today's class. I think we're out of time. So the next day we have class. Hold on. You would have seen here in posts. I'm just showing you what is like them TV shows. Next next time on 4-7 maths class, we shall be going to this question, the middle finger question. And so what you all can do is you can read the question and by all means it'll try and answer whatever you could answer from it if you could. And then when we meet up, I will go through it in detail and show you all the answers and things. But there's no reason why you can't do this as yet. Every single question here in this um, is work that we cover already, but we've never done it as a past paper before. So by all means, everybody feel free to tackle this for homework. Next day we meet, we're going to go through the answers of this question. Um,
Okay.
eh, Now that was given quite on the 15th of April, so you'll have to scroll back a bit in your posts to find it. All right then. That's it for today. Have a good day, guys.
Same to you, sir.
Yes, sir, same to
Yes.
you.
Okay, later. Bye bye.
Yes, sir.
Yes, sir.
Hmm